Warm greetings to each and everyone present here. First and foremost, we request our Vice President, Dr. Shekhar Vishwanathan, to greet our guests with a bouquet as a welcome note. Thank you. Well, greetings to each and everyone present here again for the 3 days technical symposium and mid-year meeting on advances in science and technology for sustainable future ASTSF 2025, jointly organized by the Indian National Young Academy of Science, INYAS, and sponsored research and industrial consultancy, SPORIC of Vellore Institute of Technology, Vellore. With over 1,500 participants, including rural research scholars and school students, this 3-day eve will feature 30 expert lectures, 3 high-impact panel discussions with 20 esteemed speakers, a women-centric workshop with 5 scientists, and a competitive poster presentation fostering a rich environment for knowledge exchange and mentorship. Now let's start a laudable symposium with the invocation, Tamil Thai Vartha. I request you all to kindly rise for the invocation, please.
Neerarum kadaludutha nilamadande kelilolugum சீராரும் வதனமென திகழ்வரத கண்டமிது தெக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறப்பிறை நுதலும் தரித்தணரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் வியந்த செயல் மறந்து வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே.
Special thanks to our students, Ms. Ashwati, Ms. Harshita, and Mr. Saran for your harmonious rendition. I now invite Dr. Dennis Ashok, Director Sporic VIT, to deliver the welcome address.
A very good morning to all of you. Esteemed dignitaries, respected scientists, brilliant researchers, distinguished guests on the dais and off the dais, VIT administrative heads, a very warm welcome to you, all of you. We have gathered here for the inaugural function of the 3-day National Symposium on Advances in Science and Technology for a Sustainable Future. This symposium is organized by the Indian Young Academy of Sciences, INYAS, and hosted at Vellore Institute of Technology, Vellore. It represents the voice of young scientists across the country for building sustainable future. Having said that, it's a double treat for all of us. First one being, it's a prestigious INYAS event, mid-year event, happens at VIT, and it marks the occasion of 40th year of our university's inception. So this is a Ruby Jubilee year. On behalf of Organizing Committee of Symposium at VAT, I take this opportunity to welcome our distinguished chief guest of the inaugural function, Padma Shri, Shri Kiran Kumar, Chairman, Physical Research Laboratory Management Council, Member, Space Commission, Government of India. Welcome you, sir. It's my great privilege to extend warm welcome to our guest of honors, Dr. Virendra Tiwari, Director, CSIR, Northeast Institute of Science and Technology, Vice President, Publications and Informatics, Indian National Science Academy, INSA, New Delhi. Welcome, sir. Dr. Sanjay Puri, Vice President, Resource Generation and Management, Indian National Science Academy, INSA, New Delhi. Welcome you, sir. It's my honor to welcome distinguished guests on the dais of the inaugural function, Dr. BLV Prasad, Director, Center for Nano and Soft Matter Science, SENS, Bangalore. Welcome you, sir. Dr. Gopika Vinod, Scientific Secretary and Head, Board of Research in Nuclear Sciences, Mumbai. Welcome you, ma'am. I would like to extend the hearty welcome to speakers and invited speakers of various technical events for sharing their invaluable expertise during this 3-day symposium. Special welcome to the participation of 150 school children from Yelagiri district who have joined here to witness and participate in the interactions of the scientists. From the scientist perspective, this symposium resembles like a multi-input, multi-output system with our efforts, collective efforts to get multiple unlimited opportunities of networking, innovation, knowledge enhancement, and many more through this symposium. So we thank INEA's leadership and management for providing us a great opportunity to host this prestigious event at VAT. Let's begin this journey of building sustainable future together. We wish you an inspiring and productive symposium. Hearty welcome to you, all of you. Thank you.
Thanks a lot for your earnest welcome notes, sir. I now request our dignitaries on the dais to kindly light the Kuttuvilakku as a mark of our tradition and culture.
Previously, we have worked on Model G20 initiative and a various level of school level organizations and competitions that have been encouraging the talent amongst students and scholars. So our impacts have extended beyond our national borders through various collaborations and other young academies worldwide. We have facilitated global scientific dialogue and cooperation. The academy is also participating in a lot of policy decisions and decision-making processes. In the recent years, we have made a lot of scientific progress and we have a lot of scientific milestones that we have achieved. So we have got the International Science Council membership in the recent past. This year, we became one of the few young affiliates of the Inter-Academy Partnership. And we have also established, we have also contributed to the establishment of NAYA, which is the network of Asia Pacific Young Academies this year, when we were co-hosting the Global Young Academy Conference at IIT Hyderabad, along with IIT Hyderabad and INSA. So as we are celebrating this journey, we remain dedicated to our core values of science for society, and we try to further endeavor and further amplify its impact through rural and remote area activities, contributing positively to society and advancing frontiers of science and technology and innovation. INIAS sincerely expresses its gratitude to its parent academy INSA for its support and acknowledges the effort through its members, core committee, and partners driving forward its mission. And of course, INIAS's office being managed by one person single-handedly. So coming to this specific event that we are here for, this is our mid-year meeting which we host every year. And this time's theme is Advances in Science and Technology for Sustainable Future. The symposium is organized by INIAS as a part of our mid-year meeting and serves as a timely platform for discussion and action. This prestigious event is being hosted at VIT with the full support of our VIT partners. And the symposium, as we can see, has already convened with 1,500 participants, which includes rural research scholars and school students for a meaningful and leading scientific achievement and policy experts and funding bodies. So this 3-day event is going to be power-packed with a lot of scientific discussions and a lot of panel interactions. We would request each one of you to try and participate in these activities, and whenever you get an opportunity to interact with all of us in whichever possible way. We are always there for all our students. And with this, I would like to thank everyone and would like to inaugurate this mid-year meeting of INIAS. Thank you very much. So we also would like to take this opportunity to inaugurate our INIAS half-yearly newsletter and would request you to please bring in that. We will request our, we will request Dr. Mohit and Dr. Arun Jugran as well. So please come on dais for the inauguration of this. So Dr. Arun and Dr. Mohit are our core committee members who were specifically entrusted with the activity working towards this INIAS newsletter. And we are very thankful to our editors for this issue as well.
Thanks a lot for your all-inclusive overview, sir. With the wish, this knowledge platform paves way to professionally network and initiate collaboration with various academic and industry associates, resulting in qualitative research outcomes. Well, as a token of our gratitude and respect, I request our Vice President, Dr. Shekhar Vishwanathan, to kindly honor our Chief Guest, Padma Shri Dr. A.S. Kiran Kumar, Chairman, Physical Research Laboratory Management Council, and Member, Space Commission, Government of India. I also request our VP to kindly honor our guest of honor, Dr. Virendra M. Tiwari, Director, CSIR, Northeast Institute of Science and Technology, and Vice President, Indian National Science Academy. I request our Vice Chancellor, Dr. Kanchana Bhaskaran, to kindly honor our guest of honor, Dr. Sanjay Puri, Vice President INSA and Professor at Jawaharlal Nehru University, New Delhi, India. I now request our Pro Vice Chancellor, Dr. Parthasarathi Malik, to kindly honor our guest, Dr. Gopika Vinod, Scientist H. Bhabha Atomic Research Center, Mumbai. Thank you. Welcome, sir. I request our Honorable and beloved Chancellor, sir, to kindly honor Dr. Nishant Chakravarti, chairperson INEAS, with a shawl and a memento. Thank you. Well, I now invite Dr. Kanchana Bhaskaran, Vice Chancellor VIT, to felicitate the gathering.
Good morning, all. Honorable Chancellor, sir, respected Vice President, and the Chief Guest who has joined us today, Padma Shri Dr. A.S. Kiran Kumar, Chairman, PRL Management Council and Member, Space Commission, Government of India, and the dignitaries on the dais, the Guest of Honor, Professor Sanjay Puri, Vice President INSA, JNU, New Delhi, Professor Virendra M. Tiwari, Vice President INSA, CSIR, NIST, Jorat, India, and Dr. Shakti Vadivel Duraiswamy, the convener, and Dr. Nishant Chakravarti, the chairman of INEAS, and all the other dignitaries on and off the dais, along with the conveners, the co-convener, Dr. H.S.S. Ramakrishna Mate, co-convener ASTSF, and all our deans, directors, faculty members, and particularly the participants who have come in large numbers from the school and rural researchers and the scholars, and particularly the school students and the teachers who are here to celebrate this technical symposium and to take part in it very actively. The INEAS Technical Symposium and the mid-year meeting on advances in science and technology for sustainable future, a very suitable and appropriate topic what we need to have for instilling the feeling of the sustainability. The SDG goals we have defined, but how effectively that goes for implementing in our country. In our country, we have every 5 people on the earth, every 1 in 5 lives in our India, the country. So with such a huge population, with such a big tertiary age population, it is very important that our researchers, young researchers and school students are made aware of this particular area, the sustainable future, how to really work for sustainable future, what would be the goals, what would be the opportunities for all of us to really work in that direction. And that too, VIT having got this opportunity, we feel it's a privilege where the students and the researchers who have come from afar, they can go around and see what the researchers are going on what areas we are all working, and what are the avenues for you to work in the future. So that would actually determine your directions, what you would have. That would have the seeds of idea. Therefore, I want this event to be such a great an advantage where you will have all these taken together to arrive at the directions to be set for your future. I hope you will be making all the labs visits and the facilities what we have made for you to really make use of them effectively, and the dissemination of knowledge, and to move and to really connect with your peers and the peers from VIT and the researchers from VIT. VIT particularly nationally and internationally, it is a renowned institution. We are ranked very high in the QS international ranking and the NIRF ranking, and it's a NAC accredited institution with A++ grade. And we actually, for our students, we want to provide the best form of education which is necessary for the industry at large. And as and when the industry necessities grow and change, get modified, we go for actually incorporating all of them into the offer of courses what we have. Therefore, the state-of-the-art laboratories, the dynamically changing curriculum with respect to the requirement, they are the hallmarks of VAT. And the legacy of VAT continues in this manner through what our Chancellor and the complete core group members help us, guide us and work with us in that direction. And I hope it's a great opportunity for us to host you, to host this technical symposium, and also for enabling this mid-year meeting on the particular topic, Advances in Science and Technology for Sustainable Future. I welcome you all. Have a great day. Thank you.
Thanks a lot for your felicitation, ma'am. Now it's my privilege to briefly introduce about our guest of honor, Dr. Sanjay Puri. He's a distinguished physicist and Vice President of the Indian National Science Academy, New Delhi. He's a professor at the School of Physical Sciences, Jawaharlal Nehru University, New Delhi, where he has served since 1987. Dr. Sanjay Puri obtained his PhD in physics from the University of Illinois, Urbana-Champaign in 1987. After completing his MSc at IIT Delhi and MS at UIUC. His research focuses on non-equilibrium statistical physics, phase transitions, and pattern formation with more than 250 publications in leading international journals. He has held prestigious editorial roles, including editor-in-chief of the Proceedings of INSA. It's notable to share that he is a recipient of several awards, including the Shanti Swarup Bhatnagar Prize, B.M. Birla Science Award, Homi Bhabha Fellowship, and the Visitors Award for Research in Physical Sciences by the President of India. He is an elected fellow of INSA and the Indian Academy of Sciences. With these very few words of introduction, I now humbly invite our guest of honor, Dr. Sanjay Puri, to kindly address the gathering.
Respected Chief Guest, Dr. A.S. Kiran Kumar, respected Chancellor, Professor G. Vishwanathan, respected Vice President of INSA, my colleague Dr. Tiwari, Vice Chancellor of VIT, other dignitaries on the dais, fellows of INIAS, and most important, students who are present here. I wish you all a very good morning. It's really a great privilege to be in this wonderful institution of yours and enjoy your hospitality and have the opportunity to interact with the young minds of the country on whom we rest our future hopes of development of science, knowledge, and so on and so forth. I briefly want to just quickly say something about the Indian National Science Academy. That's the organization I represent out here. It's known as INSA, INSA. And INSA is the apex body for science development in the country, basically. So we're headquartered in New Delhi. And INSA was set up in 1935, initially in Kolkata. And then finally, I think, shifted to New Delhi in 1951, as I recall, where it has been since then. It acts as a knowledge resource pool, so we have elected fellows who are sort of all experts in the various branches of science and technology. It promotes science in India. Most important role, perhaps, is it identifies and nurtures scientific talent. And that's where INIAS comes into the picture, and also you young people out there. And it provides an interface between Indian science and the global science community. So as you're all aware, science is a sort of very international practice right now. It's done by huge teams in collaboration all over the world, and it sort of provides an opportunity for Indian scientists to interface with counterparts in the rest of the world. I think about a decade ago, Dr. Chakrabarti sort of explained in some detail, about a decade ago we felt that, frankly speaking, the fellows of INSA were often sort of rather senior individuals who were perhaps not in touch with the sort of younger community of science in the country. So we actually felt the need to set up this Indian INYAS, which is the Indian Young Scientist Academy, and we're sort of honored to be attending its meeting today. INYAS has specifically focused on a younger bracket of scientists, and I think has done a remarkably good job in sort of promoting science in that sort of age bracket and at younger age brackets in the country. I want to add from my personal experience that I was for quite a while the chief editor of the proceedings of the Indian National Science Academy. It was very difficult for me. I mean, we have an excellent set of fellows. They're scientifically very good. But it was very difficult for me to get them to write in the proceedings of INSA because they felt perhaps that it would not give them the kind of exposure they wanted to on the international scene. But, and that's the point I want to make here, that INYAS was always, members of INYAS, the sort of extended community were always forthcoming with high quality articles, and the best sort of papers that came out of the proceedings were actually from INYAS members and their special issues. So I really am grateful to INYAS for that. Okay, so the last thing I want to say is, and then I should conclude, and this is to you young people out there, I realize today's social media and focus is not towards a scientific career or a technological career. But I'm at this age and stage, I've sort of been in this domain for 45 years. I would say that there's nothing better to do as a sort of practice. I mean, the way I sort of explain it to younger people is that it's the best part of my day is being in my office. And why is that? Because it's not work at all. I can sort of be in my office on a Saturday or Sunday. I can write a paper on Holi or Diwali or whatever. It doesn't matter. It's what I like to do, and it's the opportunity that I've given to do this. I want you all to sort of consider at least science as a career. The joy of doing novel things every day, not sort of repeating the routine of the office and so on and so forth, is something very unique, and I would wish for at least some of you to participate in that. With that, I think I should conclude. Thank you so much for listening to me patiently, and I'll surrender the mic now. Thank you.
Thanks a lot for your noteworthy input to take science as a career and more. Now, it's my privilege to briefly introduce our guest of honor, Dr. Virendra M. Tiwari. He holds the position of Director and J.C. Bose National Fellow, CSIR, Northeast Institute of Science and Technology, India. He is also serving as the Vice President of the Indian National Science Academy and member of International Union of Geodesy and Geophysics Bureau, which is a geoscience union of 70 member countries. He had been the director of CSIR NGRI from 2016 to 2022 and the director of NCESS Thiruvananthapuram from 2015 to 2016. Dr. Tiwari did MSc Tech in Geophysics in 1992 and PhD in Geophysics in 1998 from BHU Varanasi. His areas of specialization are gravimetry, hydrology, and geodynamics. Dr. Tiwari's research interests primarily focus on deciphering subsurface, mass distribution, and mass transport relevant to a wide range of scientific and societal applications, such as elucidating the structure and dynamics of different geological settings in the Indian lithosphere, variation in water storage over the Indian subcontinent, and mapping of sub-basaltic sediments. His current interest is integration of geophysical data sets with large-scale hydrologic modeling for management of water resources in changing scenarios. He is a recipient of the National Merit Scholarship, ONGC AEG Best Thesis Award, Young Scientist Award from INSA, CSIR, Krishnan Gold Medal by IGU, National Award by Ministry of Mines and Ministry of Earth Sciences, Government of India, and Fellowship of National Science Academy of India. Well, with these few words of introduction, I humbly invite our guest of honor, Dr. Virendra M. Tiwari, to kindly address the gathering.
Honorable Chief Guest of Day and very distinguished international scientist, former Secretary to the Government of India and Chairman ISRO, Padma Shri Dr. A.S. Kiran Kumar, a visionary leader and Chancellor of VIT, Dr. G. Viswanathan, my very dear colleague serving as Vice President in INSA and distinguished physicist known internationally, Dr. Puri, the Vice Chancellor of VIT, Vice President of VIT Society, the INEAS Chairperson, Dr. Chakravarti, members of the INEAS, and my dear students, guests, and friends. Vanakkam, good morning, and namaskar. I am really privileged and honored to be part of a galaxy which connects the very wise people, the academic leaders, and our future generation of science and technology in India. Thank you very much, INEAS, for giving me this opportunity, and VIT Vellore. Now everyone knows that INEAS, India's only recognized young scientist academy, was founded about a decade back by INSA, which provides a platform for young scientists to network, share ideas, collaborate, and participate in the science education and outreach programs nationally and internationally. I would like to emphasize, as Dr. Chakravarti has mentioned, that very recently while having their meeting in IIT Hyderabad, they connected with the Global Young Science Academy. So Young Science Academies in the world, there are very few, about 20. All advanced countries have now their Young Scientist Academy, and India has one amongst them, that is INEAS, which connects to, again, I would say, the vibrant young mind, future of the country, and visionary leaders sitting on the dais and of the dais. On the past decade, INEAS has emerged as vibrant and proactive scientific body, producing good publications and also making a good outreach programs. I would like to remind and join my colleague Professor Puri that INSA celebrates this year of 90 years its human services to the country, science and society. This is one amongst the 3 science academies which have played a significant role in promoting science in the country by honoring scientists for their achievements and also documenting the good achievements for making policies and becoming the guiding principle for future of science. Most important requirement for the today's world, which INSA nurtures, is countries' overall progress and particularly through science, and it is academy's primary objective. INSA has made science promotion a major activity, and 2 key components recognizing quality research through its fellowship and awards and honors, and also giving the inputs to the policy. Very recently, INSA has now the policy center, which is working very closely with the Niti Aayog and other government agencies of the country. I would also like to put few thoughts when a group of young scientists, in fact not a group but a very large group of vibrant young scientists, we are very much impressed by seeing some of their displays while walking from the office of the Chancellor to the auditorium. To say that science has become multidisciplinary and interdisciplinary, and particularly when today we are discussing science and technology for sustainability. And when we talk of the science of sustainability, it is science which caters the need of people, prosperity, and planet. And the solutions for them cannot be by one discipline of science. And therefore, the multidisciplinarity is our interdisciplinarity is the need of the hour. For instance, I would like to quote and remind many of you who are aware about Venki Ramakrishnan, a physicist, worked on the biological problem and won the Nobel Prize in chemistry. Whether in atomic energy, space, and weather forecasting, as a country, we have done pretty well. And one of the doyen of the missions of the space sciences, we are fortunate to have today Dr. Kiran Kumarji with us, who may share some of the very important aspects of how the science and technology has been serving to the mankind in general and country in particular. When technology was denied, we developed indigenous capabilities like supercomputing. India produces the largest number of software engineers, and India trained engineers led top software companies like Sundar Pichai in Google, Satya Nadella in Microsoft, and so on. What is now can be supplemented to this? So we have successful missions, we have good engineers and educationists, researchers, scientists leading all over the world. But what we need to do is to encourage and support the individual excellence. In my mind, if we talk of the individual excellence, there is only one person, that is none other than Sir C.V. Raman, who continues to inspire us that at the time when we did not have the large number of the facilities, technologies, instrumentation, still he could imagine and demonstrate how science can be pursued with with very meager resources, and after some time, the same science can have a large societal impact. There should be parallel efforts to develop knowledge which has been developed by a large number of researchers in the country and abroad, to translate it for the benefit of the humanity, for the society, and for the economic progress of the country. I would like to wish this very successful meeting, and I am sure that this will be more than successful when enthusiastic, curious, and having very vibrant young minds are together with visionary leaders, the mentors present today and coming 2 days. I wish once again congratulate the INEAS for this such a wonderful initiative and bringing all the people together. Thank you. Jai Hind.
Thanks a lot for your intense dissemination of inputs, sir. And now, with a round of applause as a mark of our respect, honor, and love, I now invite our Honorable and beloved Chancellor, Dr. G. Vishwanathan, to kindly deliver the presidential address.
Our chief guest of today, Padma Shri Dr. A.S. Karan Kumar, Professor Sanjay Puri, Professor Virendra Tiwari, Dr. Nishant Chakravarti, Honorable delegates from various parts of India, Vice Chancellor, Vice President, Pro-Vice Chancellor, Registrar, Convener, Dr. Sakti Vidvel, other professors and scientists, and also my dear students. Very good morning to you. I am happy that we are able to organize this symposium where people come from all parts of India are participating. I understand about 1,500 delegates are participating in today's conference. I'm very happy about it, because science and technology is going to deal with advances in science and technology for sustainable future. It's a very important subject. I want all the youngsters of this country to be part of this. Of course, it is not possible because higher education, we have a limited scope, because the GER, the gross enrollment ratio for country, is less than 30%. In all advanced countries, it varies from 60% to 100%. And I hope a day will come when all our youngsters will have an opportunity to go and study in universities and colleges. That depends on the governments, the union government and the state governments, to help the poor and the middle class to go for higher education. And then they will have an opportunity to study science and technology. I must confess that I didn't study science and technology in my college days, because I chose the art science, history, economics, political science, and law. And I remain to be a student of economics always. But I know pretty well that the economic advancement or development can take place only with science and technology. But for science and technology, no country can become a developed country. And this is a very important subject where we will have to improve every part of our area in the country, so that we will also be able to compete with the advanced countries. Out of 193 countries in the world, around 75 countries are called developed countries, because their per capita income is more than $15,000 or $20,000. We are nowhere near it. Our per capita income is $2,800 to $2,900. We have to go a long way in competing with others. I always compare ourselves with the European countries. Of course, US is also there, but European countries will be easier for us to compare and adopt, especially the Nordic countries, the northern part of Europe, Norway, Sweden, Denmark, Finland, etc., where they give education to all the children. Up to university level, education is free and do very well in science and technology. And there are more than 35 countries where they help the poor and the middle class to get higher education, so that it will be possible for all of them to go for science and technology. In higher education, I would very much like importance to be given to study science and technology. No doubt we are trying to improve, but it's not enough. And especially the improvement mostly takes place in the private sector, where people have to pay, and they don't get any help from governments. No, that's the pity of our country. We spend so much on other areas, but not on education. In this year, out of 55 lakh crores of the budget, 2.5% is allotted for education. You know how much education can help the country. Even with a limited strength of 28% GER, our students going out of the country, our people, earning there and sending back the money, what we call remittance. Ours is the highest in the world. With 28%, the remittance can be highest. What will happen if you are going to be 50 or 60%? The new education policy talks about taking this GER to 50%. It means that we will have to double the number of students who are studying in colleges and universities. There are about 4 crores of students throughout the country in all the 1,200 universities and 50,000 colleges. And again, we are the only country where our education is offered in colleges. In universities, only 10% of them are offered, because colleges, you have no freedom of any choice, and only the universities can do it. That's also another area. We have people here who can influence the decision of the government. I would very much like them to help education. Instead of giving to educational institutions, the governments are trying to collect from us. For example, the central government collects GST from all the educational institutions. I pay 18% if I construct a building. Only now the air conditioner has come down from 28% to 18%. Otherwise, we are paying 28% to purchase air condition, where everybody wants air condition now. This is the situation. The state governments also do the same. And it is time now that we realize the importance of education in science and technology and help the students and institutions and admit more students to go for higher education, so that this country can also compete with the advanced countries. No doubt we have a country of diversity, a country of contradiction, because on the one hand, the number of billionaires are increasing. On the other hand, we are unable to help the people who are living below poverty line. According to government, Niti Aayog, 18 crores of people are living below poverty line. But according to United Nations, it is 23 crores. Whatever it may be, we must be able to solve this problem so that all of them will have enough food, enough water, drinking water. Still, it's a problem in the country. There are agitations in many villages asking for protected drinking water. These are the problems we have to resolve and spend more money on such things. I see there are more than 30 countries in Europe. They never fight with each other. So they don't require much money for armed forces. There are many rivers running in Europe. I have never seen a water dispute in the courts, law courts. But is there any river in India without law disturbance, without claim, going to the court, etc.? These are things where we'll have to resolve ourselves. It requires very high maturity which can be given only by education. I hope this will be done in the future, and I thank all the participants who have come here, particularly our chief guest who was there at the helm of affairs of this country as Space Commission Chairman, Dr. A.S. Karan Kumar and other scientists. I welcome all of you. I thank all of you for participating in today's conference. I also congratulate the organizers for giving us this opportunity for our students to hear this. Thank you very much.
As always, thanks a lot for your ever-motivating words of appreciation, intense quantitative inputs twinned with commendable direction. Adiamos, sir. Well, now I invite Dr. Ramakrishna Mate, co-convener, ASTSF, to kindly introduce our chief guest, Padma Shri Dr. A.S. Kiran Kumar, Chairman, Physical Research Laboratory Management Council and member, Space Commission, Government of India.
Good morning. Finally, we are here for the main event of the day, and it's my honor and pleasure to introduce the chief guest of today, Dr. A.S. Kiran Kumar. He has served as a Secretary, Department of Space and Chairman, Indian Space Research Organization during 2015 to 2018. Shri Kiran Kumar, born on October 22nd, 1952 in Hassan, Karnataka, holds MSc degree in Physics from Bangalore University and MTech degree in Physical and Engineering from Indian Institute of Science, Bangalore. He has steered implementation of applications-oriented Indian space program, which has facilitated the rapid development of the country in many important spaces of Earth observation, communication, navigation, and space science, as well as the development of indigenous launch vehicles and related technologies for providing assured access to space. He had led design and development of more than 50 electro-optical imaging sensors flown on various spaceborne platforms starting from Bhaskara in 1979. Further, in the role of success of Chandrayaan missions and Mars orbiter mission has been significant. He's been the President, Aeronautical Society of India, Fellow of Indian National Academy of Engineering, National Academy of Sciences India, Indian Science Society of Remote Sensing, Institution of Electronics and Telecommunication Engineers. And he's also been Fellow of various academies, Gujarat Science Academy, Andhra Pradesh Academy of Sciences, and elected member of International Academy of Astronautics. He's been conferred with Honorary Causa and DSc by 18 Indian academic institutions. More than, he has also co-authored 85 publications in various national and international scientific journals. In recognition of his contributions, he was conferred with Padma Shri by the President of India in 2014. Other notable honors conferred on him include Rajyotsav Award by 2015, Shri M. Vishwesvaraya Senior Scientist State Award 2013 by Government of Karnataka. Lifetime Achievement Award from Karnataka Science and Technology Academy in 2016, IASC Distinguished Alumni Award for 2015. And he's also been honored with various prestigious things in 2018 as an International Von Karman Wings Award instituted by the Aerospace Historical Society, together with the Graduate Aerospace Laboratories at the California Institute of Technology in 2018, and the Chevalier d'Ordre National de la Legion of the Honor, the highest civilian honor by the government of France in 2019. With this brief introduction, I request our chief guest to interact with the audience, and we look forward to hearing you, sir. Thank you so much.
Good morning to all of you. Good morning. Yeah, that's better. Thank you, Honorable Founder and Vice Chancellor of VIT, the campus where we are today. Sanjay Puri ji, Virendra Tiwari ji, Vice President, and all the dignitaries on the dais, and all the young academies members, and all the students who have gathered here today. It's indeed a great honor and privilege to be part of this program, giving me an opportunity to share with you how India started making use of a capability and how Indian space program has helped the country. Probably we are all very familiar that the first object which went into space happened way back in 1957, which was a result of two superpowers post-World War II trying to compete with each other and demonstrate who is more competent and who is more capable. In this race, Russia went ahead. They put the first object into space in 1957. And if you recall, 1957 is just 10 years into independence for India. 1947 is when we got our independence after hundreds of years of external rule. And at that time, the rulers of this country were straddled with the problem of providing food, shelter, and education to its citizens. So obviously in 57, if somebody were to talk about going to space, you can see how it would have been taken. But then we had great visionary scientists in this country, Dr. Vikram Sarabhai, Homi Bhabha, and others. Dr. Sarabhai in particular, who was looking at how this phenomenal capability of going beyond planet Earth can make a significant difference to the way India addresses its problems. Because Sarabhai was aware that if you put an object in geostationary orbit, 36,000 kilometers above Earth, it can look at 1/3 of the globe continuously, and through that it can do line of sight communication. So he was clear that in India, if we have to reach out information to the entire country, in fact, what he said at that time is very interesting. See, if you have to convey a message to the entire country that time, we had about 36 crore population. If I give information to 3 people and each of them in turn give to 3 others, now you can find out how many cycles of 3 are required to reach 36 crore people. And each interaction, if it takes few hours, then how much time is required for reaching out to the entire community in the country. But if you put a satellite in geostationary orbit and transmit a signal from that, the entire country can receive it in one go. So toward this, he started his work. What he did was he convinced his friends among America, France, Russia, Germany, telling them, in India, we have a unique place near Tumba, which is a geomagnetic equator, and if you conduct upper atmospheric research there, the entire scientific community of the world will benefit. So with this in mind, he could convince his friends and also United Nations to allow us to conduct some experiments in Tumba. Sounding rockets were brought in the form of do-it-yourself kits, which we are all familiar today. And the first launch took place in India in the year 1963, November 23rd. And even for conducting that experiment, Dr. Sarabhai had to convince the fishermen in that region, telling them that you allow us to conduct this rocket experiment, one day the country will benefit. And even for doing that, he had to make use of the services of the priest of a church. Many of you would have seen in our many ISRO pictures one dilapidated church which is now converted into a museum. So he used the help of the priest there to convince the fishermen. And then, as though what he had promised became a reality, 1999 onwards, what ISRO had done was, by looking at the color of the ocean through an orbiting satellite, identify the chlorophyll, and through that, the food chain of the fish, it was possible to tell the fisherman where exactly in the ocean, if he goes, he is assured of a fish catch. You can realize that this particular activity, which started in 1999 onwards, provides specific information to lakhs of fishermen of the 11,500 kilometer long coastline of India. And this activity alone saves to the country between 10 to 15,000 crores a year, because the fisherman now doesn't have to spend extra petrol and diesel, and he can reach the place where he catches the fish directly. And recently, with our own navigation satellite, we have added new capabilities. A small battery-operated gadget is fitted into the boat of the fisherman. And you know, when you go few kilometers or few hundreds of meters away from a tower, no terrestrial tower can reach your mobile. But a mobile in the hands of the fisherman, which can interact with this battery-operated gadget in his boat, communicates with navigation satellite, and the mobile with an app points to the fisherman where he has to go for fishing in a video compass mode, and also gives him alerts in his mother tongue if in the coming days weather is going to be unbearable or sea state roughness is going to be such that he cannot navigate. So you can see here an example of a person who does not know reading or writing being able to make use of the most advanced technology of a rocket, putting a satellite into orbit, and through that, in his hand, receiving information for his livelihood. In a very similar manner, one thing that was done in the early 70s, in fact, Dr. Sarabhai was also able to convince American at that time, telling them one of the most advanced technology satellites which they were building at that time, called ATSF, it was borrowed by India, moved over to Indian longitude, and for 1 year, India conducted a unique experiment. An experiment where, by receiving the signal from this satellite, in 2,400 villages of our country, in 6 most backward states, at a time when only 4 metros had the privilege of looking at broadcasting: Bombay, Delhi, Calcutta, and Madras. Rest of the places were not even seeing television. At that time, ISRO conducted the world's largest socio-technological experiment by making use of an American-built satellite. And we are all very familiar today, direct-to-home television. A small quarter-meter antenna on our rooftop, a small set-top box on the table, we are able to see the broadcasting. You imagine in 1975, India conducted the preliminary concept of this called direct-to-community television sets with half a rack of hardware, electronics hardware, and a 10-foot diameter antenna on ground. And using this, India and ISRO showcased to the country that if we have to bring in communication revolution in the country, it's only possible through space technology. And this experiment, which was done in 1975, in fact, this year we are celebrating the 50th year of this event called Satellite Instructional Television Experiment. You can also imagine if in 75 you tell the powers that be in Delhi that what you are speaking can be heard all over the country at the same time. Do you think more convincing is required for any project to get approved? But then that was the way India demonstrated that by borrowing an advanced technology satellite built by America, you also need to appreciate the satellite that was built by Americans at that time had a lifetime of only 2 years. And we wanted to use it for 1 year. And that means, though it was an advanced technology satellite they were building, they were ready to provide to us because they saw in that an opportunity to do proof of concept of direct-to-home television, which we demonstrated as direct-to-community sets. In a very similar manner, what India did also was in weather monitoring. You know, in the earlier decades, whenever a super cyclone comes, we used to have tens of thousands of people losing their lives. But today, by using satellites in geostationary orbit, by looking at the Indian subcontinent continuously and looking at the cloud patterns and the various parameters you extract, we are in a position to tell the disaster relief agencies well in advance where in the coastline a cyclone comes, days in advance, and both time and location fairly accurately, so that disaster relief agencies are evacuating people and saving their lives. This is how you can see in the recent past, even super cyclones when they come, the loss of life is reduced to a single digit. Now, why I am telling you all this is, India is the only country which started using space activity for non-military application. Every other country started its space program for demonstrating its military might. And it is here that how science and technology can be used not only for the development of the country, but also for benefiting. Today, with the satellites in operation, it's also being used for finding out where to drill a borewell on the ground, and then what is the crop yield. More than 20 crops are being assessed before harvesting. And also you saw very recently on the July 30th of this month, we launched a satellite called NISR, NASA ISRO Synthetic Aperture Radar. Now I'd just like to showcase to you, in 1975, we borrowed an American satellite and used it for demonstrating site or broadcasting service. On July 30th of this year, India launched this satellite. This satellite itself costs about $1.5 billion. More than 1.3 billion is spent by America. We spend only 0.2. But it's a joint mission where a payload which is capable of looking at the entire globe every 12 days, it is like monitoring the health of the earth. For humans, we have pulse rate, heart rate, and temperature, etc. being monitored by sensors on 24/7. Then you can predict what is going to be health in the coming days and months. So in a similar manner, today the world has a unique capability of making use of this satellite. It provides observation of Earth in atmosphere, land, ocean, and cryosphere. And every 12 days it can cover the entire globe. And you can study the changes to the tune of even millimeter changes that happen on the surface. Now this particular satellite is a joint mission between India and USA. And you can also see in the past 5 decades how India has moved from borrowing a satellite and taking help of others to a time when you launched one of the most advanced satellite which is going to be beneficial for the entire humanity. And in the coming years, this satellite alone generates more information than all the Earth observation satellites built so far. And all this data is going to be available to the entire scientific community of the world, and a huge amount of investigation, model making is going to happen with this. And in the meantime, you also know that space technology, because of its very nature, does not allow easy exchange of information. So India started its building capability of launch vehicle, satellite, step by step. Initially, when Russia allowed us to conduct an experiment, with their help, we launched a couple of satellites, Aryabhata, Bhaskara. And then gradually we built our own launch vehicles. And also, you know, when cryogenic engine, one superpower was ready to give, other superpower ensured that that technology transfer did not happen. But it paved the way for India to develop its own indigenous cryo engines. And today, India has launched not only hundreds of its own satellites, but more than 400 satellites of 34 other countries, including in one go, when 104 satellites were launched in a single launch. It was a unique event. While all this is happening, the world has grown. India, from its very low position in the economic ladder at the time of independence, today it has grown to the almost the 4th largest economy. And as we keep increasing our capability, because of the very friendly neighbors we have, we cannot but afford to make use of all the technological capability we have for benefiting. Though India started its space program for non-military activities, today you are forced to use it because you know human nature is conquering things. Man conquered land, ocean, airspace. Today he is looking at space as a new frontier. Space is being looked at as space for tourism, space for adventure, space for habitation, space for exploitation. All this is going on. And India also, by virtue of the technological capabilities that built, also wants to make sure that if in the coming decades and by the time we reach our 100th year of independence, if we have to be among the top, you should be competent, and your competence will be recognized only when it is demonstrated. So like I said, we borrowed an American satellite earlier, but when we launched this time, we were competing, or we are actually collaborating with them. People will recognize you only when you build competence. America was never ready to do a collaborative work mission with ISRO until India demonstrated our Chandrayaan-1 mission and many radar satellites which we built on our own. When that was done, they were ready to work with us on a common mission. And then India not only showcased in Chandrayaan-1 mission, by that time, man had landed on the moon, a large number of probes had touched the surface of the moon. But still, Chandrayaan-1 gets the credit for discovering the presence of water molecule and also the process of water molecule formation. The credit for discovering this goes to Chandrayaan-1, which showcases to you that in the area of science and technology, it is never too late. There are always things which you can find which others have not done. In a similar manner, when we did our Mars mission in 2013, on November 5th, we launched a satellite from Sriharikota. What was the task cut out for that satellite? Travel a distance of about 60 crore kilometers over a period of 10 months, and at the end of that period, on a specific day and time, 2014, September 24, morning 7:30 a.m., to that second, you imagine in space a 50-kilometer cube. If the satellite, after this much 10 months of travel, if it were not inside that cube, at that second, it would not have been possible for us to make that satellite go around Mars. And in fact, India became the first country in the world to do this in its maiden attempt. This also showcases to you that the capability of Indians is enormous. And then, in a similar manner, we have also showcased that using the space technology, the requirements of the country, a whole lot of them can be met. And you also know on the 23rd of August 2023, when India landed its Vikram lander and Pragyan rover in a region where nobody else had gone so far. And again, it was a demonstration of the intrinsic capability. But then, why am I telling you all this in this occasion? Just two basic points. One is, ISRO demonstrated to the country that use of science and technology has to be for the benefit of the country. For a country which was at a very low level in the economic zone at that time, how to provide communication, broadcasting, weather monitoring information, and also how to provide information about the various crops, crop estimation, and then doing all this with technology that is accessible to you. What is not accessible, you build your own, but all the time, think of solving problems which you are facing with what you can get access to. And it is here that though India started the program much later, etc., globally it is recognized that India has put the space technology to maximum use for its development in the country. And earlier, we also used this space technology for telemedicine, teleeducation, linking people from remote places like Andaman Nicobars to super specialty hospitals, or at a time when communication was not well established, how to reach out to the remote classrooms. So in all this, the whole idea was how to make use of the space technology for enabling the country's activities and address problems one by one. Today, as it has grown in capability, India has already decided that in the next couple of years, we will have our own humans or Gagannauts going around Earth. By 2035, we will have our own space station. and by 2040, we will have Indians landing on the moon and coming back. And you can see here, there is a tremendous opportunity in the area of science and technology. In any area of science and technology, if you have to go ahead, you have to work on problems which are much more challenging. That's how ISRO demonstrated step by step, building SLV, ASLV, PSLV, GSLV, going to near Earth orbit, geostationary orbit, going to moon at 380,000 kilometers, or Mars, 200 million kilometers away. So like this, step by step, you build your capability, enhance the capability you have, and during that process, build the industry and the supporting environment. Today, the government has already made all these targets known, and there is a huge opportunity for science and technology people to address problems, not for the sake of looking at only what is happening outside, but using all that technological capability to address problems we face. And in this context, I would like to give you a couple of examples of how India looks at the problems very differently. On one of the days, I had an interaction with one of the professors who is actually MBBS doctor who came out to the Mysore Medical College. He, along with 5 of his friends, when he came out to his medical college, decided he will set up an institution for providing education and health service to tribal children. So he involves himself with many such activities. In one of the narratives, he told that he was going along with a father and son in a forest. Now the son climbs a tall tree. He has a blanket. He puts a blanket around himself, and there is a the beehive. He picks the queen bee from the beehive, puts it on his shoulder, and all the bees come over to his body. With a sickle in his hand, he chops off 1/4 of the beehive, which is collected by the father on the ground on a blanket. Now son puts the queen bee back, all the bees go back to the beehive, he climbs down. Now the management professor asks the father, see, we all teach in our education, in management, whatever we do, we should maximize our returns. But here I am seeing your son leaving 3/4 of the beehive there and picking up only 1/4. Why are you doing that? What the father tells is worth noting. Father tells, as it is we are eating into the fruits of the bee colony. We need to take the honey only for the needs of the medicinal value it has got for our children. We should not over-exploit. So you also know that there is enough on this planet Earth for survival. And if one were to live the style of the Western world, it is said we require about 6.5 times the Earth resources for survival. And if you live like maybe Nepal, Bangladesh, India, maybe less than half of the Earth resource is sufficient. And then you also saw how India dealt with the problem of COVID. In the COVID scenario, today you also need to realize any technological growth, scientific finding, new discovery becomes actually a tool for somebody to build an empire around that and build a huge financial advantage from that. But then in doing rapid development, many times you cause all secondary or even primary impact where living on planet Earth itself becomes very difficult. You have seen the excessive use of fertilizer, how it has spoiled the soil. Use of plastics, and in similar manner, when COVID came, everybody was looking at how can we take advantage of this scenario. It is only India which not only found a solution to the problems it is facing by finding its own vaccination, but it also provided it to others, not for economic benefit. And similarly, if you look at all our software engineers were being made fun of. They were being told, you are all e-coolies. But then it is the same e-coolies who broke the backbone of the financial tech system today by bringing in digital stack. Why I'm giving you these two examples is the way India thinks is very different. Here, people are very clear that human life, for its survival, requires all other forms of life also to be recognized. Even COVID showed you that. And in a very similar manner, nature needs to be respected or preserved if life has to survive on planet Earth. And it is here that India has a great responsibility of not only showcasing to the world that if human race has to survive, not only should it explore, it should explore, it should build newer and newer capabilities, provide better tools for survival and living. But in doing all this, keep this in mind that you should not over-exploit. And that is where the topic of this also is advances in science and technology for sustainable future. Sustainable future means, should we do our development to such an extent that we leave a trail of disaster on this planet Earth and we have to go out of planet Earth or to other places in the universe? Or we should ensure that this planet Earth remains livable and then explore the external world? That is for you to decide, because this land has always shown that human being is the explorer of this universe. And maybe I'll just spend a couple of minutes giving you a different perspective on this human system itself. If we are the explorers of this universe, what do we have with us which is available to us 24/7? I'm not sure every one of you spend enough time trying to comprehend how you as a system perform. See, today we are all very familiar with our exploratory robots which we send to Moon, Mars, etc. We build robotic system which has got some input taking mechanism for it to take the inputs. Sensors are there. Some actuators using which we can make it function. We put a controller in that, and that controller, unless it gives the instructions to the actuator, no actuator can function. So we make use of storing instructions in one memory, and using those instructions, the controller can perform actions. But many times what we have designed, if it is going beyond the design limit, it might fail. So we build fail-safe mechanism. That means, just to explain, suppose I have built a robotic arm to lift a 5 kg water bottle, but the robot does not know what it is lifting. It simply follows the instruction, picks it up. But if the object is much heavier than the design, obviously the arm can get damaged. So I'll say, let me build a fail-safe feature in that. So I'll put a fail-safe design which will make it realize what it is doing, is it within its control limits or design limits. So you have a second memory which stores instructions for self-sustenance, self-preservation and self-protection. So my robotic system has 5 elements: sensors, actuators, controller, one memory for external function containing instruction for external function, another memory for self-preservation, self-protection. Now suppose I ask any one of you a question: can you map these 5 elements to yourself? Do you see any parallel? Do you think each one of you are endowed with all these 5 basic elements of a robotic system? Anybody wants to take a guess and answer? Do we have all these 5 elements within us? Okay, maybe sensors. We can say, what are the sensors we have? We have 5 gnanendriyas. Using these 5 gnanendriyas, all the inputs we take in. That means the sensors are there. But this is a difficult question. How many karmendriyas we have using which we do all our external functions? If I ask that question, not many are able to exactly identify the 5 actuators using which we perform all our activities. Anybody wants to take a guess? At least 1 or 2 you can tell. Hands. Then? Not mouth, the voice generation. complete voice generation requires lot more mechanism. Your mouth, tongue, and even the sound which gets originated. So hands, legs, voice. Now 2 more are there. We are supposed to be having 5 karmendriyas, using which we do external functions of this body. But anyway, I'll leave it as a homework for you to guess. I'll leave it there. And obviously, all of us realize that we have a control system which is working for us. Now that controller, whether it is only the brain or something more, you can work out. But definitely, you will say there is a control system working within you. What I say is, there is an asli intelligence system within you which is taking care of, taking sensory inputs, building its own ability to survive and then grow. For example, if you take a child, why do we think the child learns the mother tongue? As a question if you pose, the way we can look at is, when the child enters the world, it has got all these 5 elements. It has got a controller, it has got actuators, sensors, but only sound it is receiving from surrounding. The controller tries to make sense out of it and tries to build its own ability to speak. That means it starts generating commands to give to its voice generation system, and by that process, it mimics what is happening in the world. So in a way, we can say the controller has a design feature which says, mimic what is happening around you and evolve yourself. With this, you keep storing one memory, and that's what you use for your future course of action. But then there is another memory which contains instructions for self-preservation and self-protection. Anyway, I'll leave it as a guesswork for you to think of how it comes to you, what it does, because this dialogue can go on for 2 very long time. I'll just stop here, but my point of telling you this is very important. Each one of us enter this world with these basic elements, and we grow in this world by virtue of what kind of interactions we get, stimulus we get, and the asli intelligence we have, we make use of for our evolution. Today, what human being or science and technologies have been doing in this world is all the time enhance the capabilities of these actuators or even sensors. For example, if you see, your eye can see only between 400 to 700 nanometers. But today, you know, there are so many life forms which can see beyond this. And you will be also remembering there are so many gadgets humans have built which will enable you to look at what is happening in the world which your eye cannot see. You can guess what all has been done. Similarly, if you look at walking, humans could walk only a few kilometers an hour. But today, how many gadgets and tools you have built which can take you to maybe very soon any part of the globe in less than half an hour. So you are building, that means human looks at what is happening around him through that build tools step by step. And today he is trying to build, one of the design challenges of today is, suppose somebody were to tell you, can you build a car or a robot which can reproduce itself by picking up raw material from surrounding it? Now you think of any life form, plant forms to insects, any life form. Aren't all these life forms reproducing themselves by taking the same 5 panchabhutas which we know? Every life form is capable of reproducing itself. Human being is today trying to reproduce such a capability by using non-living material. We are still a long way to go, but human beings trying to mimic nature and produce. So all of you have a fantastic opportunity. Universe has so many new things to tell us. We know very little. And then today, quantum, artificial intelligence, they're all moving in such a pace. But I only want to remind you that you have within you a huge potential, huge capability. If you start exploring yourself and try to understand how your system is functioning, you can make better use of it, because this is available to you 24/7. So with this, I'll stop. Wishing you all a great success in your effort and in your ability to make this land again a numero uno in this world by 2047. Thank you very much.
A humble and sincere thanks for your exceptional and significant inaugural address, sir. Thank you so very much. Now it's time to honor the winners of various competition. We request our chief guest, our VP, Vice President, sir, and dignitaries on the dais to kindly honor the winners. The winners of the competition, Go Nano Micro, World of Microscopy Image Art Competition, are the first prize goes to Mr. Adash, PhD scholar, IPCL, CSIR, CLRI, Chennai. Certificates? Yeah. Pinnadi, just go back. Yeah. The second prize goes to Ms. Sharada Dayanand Mohit, PhD scholar, CSIR, National Chemical Laboratory, Pune. The winners of the competition, Quiz Nova, the first prize goes to Ms. Nihara, Department of Chemistry, University of Kerala. Yeah, please go ahead. That's fine. Yeah, you can join as a team. Yeah, please, please. The second prize goes to Ms. Setu Lakshmi, Department of Chemistry, University of Kerala. Okay. The winners of the competition and environmental pollution science quiz, the first prize goes to Mr. Lakshmanan, Dwarka Das Govardhan, Das Vaishnav College, Chennai. The second prize goes to Ms. Ritika from Dwarka Das Govardhan, Das Vaishnav College, Chennai. Hearty congratulations to all the winners and to all the participants, and thanks a lot to the dignitaries. I now invite Dr. Shakti Vadivel Duraisamy, convener ASTSF, to kindly deliver the word of thanks.
Very good morning to one and all present here. Thank you is not just a phrase, it's a sincere expression that cannot be seen or touched, but must be felt from our heart. I feel truly honored and privileged to have the opportunity to deliver the vote of thanks on this special occasion. On behalf of the INIA's mid-year meeting and symposium organizing committee, I would like to extend my sincere heartfelt thanks to our honorable chief guest, Padma Shri Kiran Kumar sir, Chairman Physical Research Laboratory and former Chairperson of ISRO. I also extend my thanks to Dr. Virendra M. Tiwari, Vice President INSA and Director NIST, and Dr. Sanjay Puri, Vice President INSA and Professor JNU. I extend my sincere thanks to Dr. Gopika ma'am. She is the scientific head of BRNS who graced us with this esteemed presence. I extend our heartfelt gratitude and deep regards to our Honorable Chancellor sir for graciously accepting our proposals to host this prestigious event at Vellore Institute of Technology, Vellore. I would also like to express my sincere gratitude to our respected Vice President sir, Shekhar sir, Executive Director and Assistant Vice President for their valuable support, encouragement and guidance. I express my sincere gratitude to our respected Vice Chancellor ma'am for her valuable inputs and thoughtful contributions. I would also like to express my sincere gratitude to our respected Pro-Vice Chancellor sir for being instrumental in organizing this prestigious event. I remain deeply thankful to our Registrar ma'am for her constant support in all aspects. My special thanks to our former chairpersons, Dr. Anandita, Dr. Chandra, Dr. Rajendra, for their valuable inputs and support. I would also thank our Director Sporik for his constant support and guidance, and I also thank the Deputy Director and Assistant Director of the sponsored research for their unwavering support. We will remain grateful to our team members of the Sporik And also I extend my sincere thanks to our research dean for making these all arrangements. I thank the special thanks to our headmaster from Elagiri Hills and also assistant headmaster, teachers and students from the Athanavur Government Higher Secondary School for making this event even better and a grand success. I sincerely thank the dedicated faculty committee members and also student volunteers for the grand success of this event. I am very much thankful to the national funding agencies such as DST ANRF, DA BRNS, INSA, DST and ICSSR. It would have been never possible to organize this event without your support. Thank you very much for the funding supports from various funding agencies. It is time to express my heartfelt gratitude to the VIT management for their gracious financial support, which played a vital role in making this event possible at such a grand scale. So I extend my sincere thanks to all the respected deans, directors and associate deans of the various schools and centers, head of the departments of the various departments and our respected faculty colleagues for their wholehearted contributions and unwavering support in making this event a grand success. I take this opportunity to express my heartfelt thanks to our present chair, Dr. Nishant, Dr. Kalpana, the secretary, the core committee members of INYAS, especially Dr. Matte, the co-convener of this event, and also the wonderful and current alumni members of our INYAS. Also, I extend my thanks to Ms. Ananya from INSA for their immense support, dedication, and contributions. Thank you all for your invaluable contributions in making this event a grand success. Have a wonderful stay at VIT, Vellore. Enjoy the mid-year meeting and symposium and also our beautiful campus life of VIT Vellore. Tottanai Thorum Manarkeni Mandarku Kattanai Thorum Arivu. Tirukkural by Thiruvalluvar. Just as a sand spring yields water when touched, a learned person's wisdom flows when prompted. Thank you very much for your wonderful presence. Thank you very much.
Well, wishing each and everyone to have an extensive knowledge sharing days ahead. There'll be a group photo, followed by which we'll just proceed. As there's another important function, we'll just, yeah, okay. The participants you can have. Yeah, please. The students kindly stay back. You have on duty till 1 p.m. You have a very good opportunity to interact with the intellectual assets here. And snacks are arranged outside the auditorium for all the participants. And session will start at 12 o'clock.